Hey, welcome back, guys. This is Professor Rodan with Explorations in Math 12.2. This is Frequency Distributions and Statistical Graphs. So let's take a look in your workbook in 12.4 here. As far as the page numbers concerned, this is Chapter 12, page 4. And so basically, this section's all about organizing data. So the data has already been collected through surveys or whatnot. So this is part of the organizing, and then 12.3 is more drawing inferences and things like that. So let's take a look at number 28. So unfortunately, that's a typo. It should be number 28, okay? It talks about salary. Now, what exactly is a frequency distribution? So a frequency distribution is basically a listing of the observed values. So you conduct the experiment or the survey, and you start writing down the numbers, and then the corresponding frequency of each occurrence. So for example, in number 28, we have starting salary, and this starting salary is with a bachelor's degree in the field of social science. So Bachelor of Science degree for social workers, and not sure what year this is, but so this is a survey of 25 different social workers, and it's a random sample, and this is no experience, it's straight out of college. And so these are the different salaries that they made, and of course it depends on the company that you work for and the area and things like that. So before we actually write the information in here, I want to go over a couple rules that we're going to use for organizing the data. So first of all, you can get these rules on page 735. Okay, so first of all, when we group the data, we call them classes. Okay, so how are you going to organize it into classes? So these are just the categories that we want to use so that we can kind of divide our data into different groups. So the first thing is that the classes or categories should be the same width, okay? In other words, from what number to what number are we going to use? Every single category is going to be equal width. Okay, of course that's not a physical width. That is just as far as the numbers go in our set. So the second rule will be that the classes should not overlap. So we'll see an example of that in a minute. So you don't want two groups overlapping. You want to have everything separate. And then each piece of data it should only belong to one class. Okay? So let's see what we mean by that. So if you take a look at example number 28, starting salaries is already in order for you. So this is in thousands. So 27,000. 28,000. So remember, this is 25 people that were surveyed. So a bunch of people with 28,000. And this is per year salary. A couple 29s. Some 30s. 31, 32, 33, and the highest salary was 34,000 per year. So it wants us to construct the frequency distribution with a width of 1. So it says, so class width of of 1. So that means we're not gonna make, let's say, 27 and 28 in one class. We're not gonna combine classes. Every single salary here is gonna be its own class of 1. Okay, so for example, starting salary, we have 27,000, 28, 29, 30, 31, 32, 33, and 34. So that's what we mean by class width of 1. If it would have said class width of 3, that means we would combine 27, 28, and 29. That would be a class width of 3. Okay, or a class width of 2 would just be those two, those two, those two, those two. So that is what we mean by that. So now we just want to count. Okay, so the first thing is we want to count how many 27s there are. And obviously there's only one right there. And then 28s, we have 1, 2, 3, 4, 5, 6, 7. 29s, we have 1, 2, 3, 4. 30s, we have 1, 2. 31, we also have 2. I'm sorry, 30, we have 3. 31, we have 2. Okay, 32, we have 1, 2, 3 as well. 33, we have 3. And 34, we have 2. Okay, those are the frequency of the occurrences of these salaries for the people that were surveyed, the random sample. And that is it for frequency distribution. Okay? Now, we can see we can check to see if this is correct by adding up all these numbers. So 1 plus 7 is 8, 8 plus 4 is 12, 12 plus 3 is 15, 15 plus 2 is 17, 20, 23, 22. So we have 25 total, and that's what we expected. That was from the word problem itself. Okay, so there was 25 different social workers. So next, let's construct a histogram. So histogram is basically a bar graph. Okay, so what we're going to do is put our frequency over here, and we're going to put our salary over here. That's all. So we have 27, 28, 29, 30, 31, 32, 33, and 34,000. And then the frequency goes up to about 7. So we can do 1, 2, 3, 4, 5, 6, 7. Okay. So again, we use the same numbers we just used in our frequency distribution chart. So 27, there's only one, so we're going to draw a bar graph there. 28, there are 7. Okay, 29, there are 4. 30, there are 3. 31 was 2. 32 was 3. 33 was 3. And 34 was 2. Okay, so there's our bar graph, which is called a histogram. Okay, now the next one is called the frequency polygon. It looks similar to this, except we're going to draw, we're going to put dots at the top of these, and then we're going to connect the dots to make a polygon. Okay, so let's set this up again. So we have 27, 28, 29, 30, 31, 32, 33, 34. Then we have 1, 2, 3, 4, 5, 6, 7. Okay? Now, so this time we're just going to do the dots. So 27 has 1. 28 has 7. 29 has just a second. 27, 28, 29. So 29 has 4. 30 has 3. 31 has 2. 32 has 3. 33 has 3. And 34 has 2. So if you connect the dots, okay, that is not a polygon. Okay, the definition of a polygon is it is enclosed figure. So enclosed means there's no open spaces. So we have to finish this down to 0. Okay? Now it's a polygon. Okay? So we connect this right here. Polygon is an enclosed figure. So those are kind of some trick questions you'll see in the multiple choice, not only in the homework, but also on the test. Where this, for a polygon to be a polygon, you must enclose it completely by finishing the graph, even though there's nothing there. Technically, this is 0 for both cases. Okay? So don't forget about that. Some people complain about that, but that is technically the definition of a polygon, is make sure you enclose the figure all the way down. Next, we have a stem and leaf display. So stem and leaf is exactly what that means. You have a stem, and then you have leaves, okay? So let's say the stem could be a 2 for the 20s. So 20 what? So you might have 21, 22, 25, 27, 28. Okay. So we put the stem over here. And then these are the leaves. So, for example, we have 27 occurs once. So that's the stem is 2, the leaf is 7, and then we have a bunch of 28s. So instead of writing 28, we're just going to write 8 7 times. 3, 4, 5, 6, 7. And we have 3 29s, so we're going to write 4 29s, which is 4 9s. Okay. And then the other stem, we have a bunch of 30s. And we have 3 30s, 2 31s, 3 32s, 3 33s, and 2 34s. And that is a stem and leaf display. Okay, just another way of looking at the data by not repeating the same digits over and over again, as far as the 20s and the 30s go. Okay, so that's it for stem and leaf display. Now the last thing is the circle graph. You guys should know what that is and how to interpret that, but you won't have to actually create the circle graph necessarily. Most of these are going to be done for you, but let's just say we had to create one for this example. So first of all, so we want to say, okay, well, what's our data look like? Well, we have 27,000. We have 28, 29, 30, 31, 32, 33, 34. And for each of these, what we want to do is figure out the percentage out of 100. So the whole graph is going to be 100%. So we want to split this up, let's say into fourths. So we know that each of these fourths are 25% each. Okay, so then 27,000, for example, we want to do part over whole. So we want to do 27,000. We only have one of those out of 25 total. And if you put this in your calculator, you get 0.04. Oh, Lord. So that's 4%. Okay, really small. That's going to be the smallest one. So the biggest one is going to be the next one, which is 7 out of 25, which is 0.28, which is 28%. That's going to be our biggest one. So we can actually go ahead and graph this one. 28%, we know this is 25%. So 28% is probably right there or so. Okay, just as an estimate. So this is our biggest category. That's an approximate 28%. Okay. Now, let's figure out the other percentages, which will be 4 to 2. By the way, Excel, if you type these numbers in an Excel spreadsheet, you can highlight these numbers and it'll calculate these for you and actually put these on a, if you know how to choose the right graph, it'll actually give you a circle graph. Okay, so we have 3 out of 25. We have 2 out of 25, which is 0.08, which is 8%. We have 3 out of 25. Again, another 12%. So all right. Well, as you can see, our next biggest will be our 12s. So we know that half of 25 is about 12 and a half. So we can just estimate that these guys will be about right here. That's 12%. That's another 12%. And this is another 12%. Okay, then we have 10% and 8%, which are very similar. So 10% will probably right there. 8%, 8%, and let's see, 1, 2, 3, 1, 2, 3. Yeah, this didn't really come out that great because 4% is a little bit too big. Actually, I can do that right there. 4%. That looks about right. So that's kind of tedious, not very effective, but it gets the job done. And you can see these are about 12s, and we have 10 here, and then you have 8 and 8 here. Okay, and then you have 4%. So actually, in for your work, you're gonna have to do something else with the circle. So when you guys do the work, let's just go ahead and go straight to an example. Let's go to number 35, I believe. Yeah, 35. So number 35. The circle's already drawn, thank God. Okay. And this is the University of Virginia in 2014. Total cost to attend, $20,986. That is basically 100%. Okay, that's the whole amount. But this divides. Let's see, tuition is not quite 50%. That's 48%. Then we have the cheapest would be, so that's the most expensive is tuition. Cheapest would be books and supplies, which is 6%. And then you have, sorry about that. So 21% for housing, and then for food, and then 25% for housing. Room and board is what they call it. All right, so your job is basically, okay, how much did each of these portions cost? So that's pretty straightforward. You guys know how to do 0.48 times the total, and that'll give you 10,073 and 28 cents. Okay, that's this part right here, 10,000. And then this part right here is going to be 0.25 times 20,986, which is 5,246 and 50 cents. And this one is going to be 0.21 times our total amount, which is going to give us 4,407 and 6 cents. And then the cheapest amount will be 6% of the total, 1,259 and 16 cents. Okay, so that's what you have to do for your homework. All right, I do want to take a look at number 33 as well. Number 33 is an application question. Okay, so here's number 33. Email messages. Use the frequency polygon below to answer the following questions. So, if number of email messages sent per day. So, we have 3 emails all the way up to 10 emails. And then using the survey, organized information, how many people, let's say this one right here, 3 emails corresponds to 2 people, okay? So that's how we're going to look at this frequency polygon. Notice how it does continue to, it continues to 0, even though there's no category there or a class number or anything, but you have to complete the diagram to make it a polygon, okay? So the first question is, how many people sent 5 email messages? All right, so here's 5, and we go up, and we can see that there are 7. Okay. How many people sent 6 or fewer? So 6 or fewer. Six or fewer would be right here, and everything to the left of this. Okay, so we have 2, 3, 7, and 4. So 2 plus 3 plus 7 plus 4, that's going to equal 10, so that's going to be equal to 16. Okay. Okay, how many people were included in the survey? Okay, that means that we need to figure out all the numbers. So this is 2, 3, 7, 4, 3, 8, 6, and 3. Okay, so if we add those up, actually we can add up everything from 6 and to the left is 16. Okay, and then we're going to add, so we know that from there to the left is 16, so we're going to add up the other numbers. 3 plus 8 plus 6 plus 3. And that's going to equal to, what do we have here? So that's going to equal to 36. Okay. Now we need to use that information to construct a frequency distribution. Okay, so that means, so this is letter D. We want to do messages. And we want to do number of people. So the messages go from 3 to 10, and then we count the people. So we just go, not count the people, we just look at the numbers we've already labeled. So it's going to be 2, 3, 7, 4, 3, 8, 6, and 3. Okay, and there's our frequency distribution with a class of 1. Now, a histogram of the same information. So 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 1 to 10 as well. So 3 is going to be 2. 4 is going to be 3. 5 is going to be 7. Actually, let me label this. So 1, 2, 3, 4, 5. So 7 is going to be up here. 4. 7 is going to be 3. 8 is going to be 8. 9 is going to be 6, so it's about right there. And 10 has 3, which is about right there. All right. So that basically does it for number 33. Some application questions regarding these concepts. So again, that's all we have for frequency distributions and statistical graphs. Okay, make sure you learn each of the graphs that were presented, and we will see you in the next video.